Hello, mathletes. We are moving on today and looking at geometric sequences, which is our next type of sequence. So you will want that next foldable, right? The one that says geometric sequences on it. And it looks like this. So, nope, that's exponential growth and decay. Sorry, but it's the same color. It looks like this, right? With example 1, 2, and 3, and then your geometric sequence on the bottom, and then your notes on the back. So, just like the arithmetic sequence foldable, this is what you want it to look like. So, we're kind of folding it into thirds and then tucking the, sorry, my dog's trying to eat it or something, tucking the example 1, 2, and 3 underneath. So this is kind of what you want the end goal to look like here. So if you have not made that foldable yet, please do so. All of our notes are going to be in that foldable. So you would want to just pause the video and make that foldable. Make sure that you get the title of the notes for today, which is geometric sequences, and today's date. All right, so here is the foldable, right? So there's example 1, 2, 3 on top. On the bottom, it says geometric sequences. And so we're going to start with kind of defining what is a geometric sequence. So if we remember a geometric, my dog's going to be in the video for today. My geometric sequence or my arithmetic sequence was something that adds the same number every time, right? Plus 7, plus 7, plus 7, or subtracts like minus 5, minus 5, minus 5. So geometric sequence is a little different, right? It's a sequence, obviously, so it's still a pattern. So a sequence or pattern that multiplies or divides by the same number every time. Same number every time. So instead of adding or subtracting the same number every time, it's multiplying or dividing by the same number every time. So, like an example here is I go from 1 to 5. Well, in order to do that, I multiply by 5, right? And then from 5 to 25, I multiply by 5. And I can keep going, but in this case, I multiply by 5 every time. Now, if you were presented with a sequence that you had no idea if you were multiplying or dividing by the same number every time, okay, there's a way to find the common ratio, which is the number that you're using every single time. So we're going to say, make a little note here, to find the common ratio. So if you're like, I have no idea what I would multiply by, what you do is you take your second term, so a sub 2, right? And you divide it by your first term, which is a sub 1. In this case, my second term is 5, and I divide it by my first term, which is 1, so I get 5. So that tells me that my R equals 5. The common ratio is 5. We don't use D in these equations because that's common difference. That's adding, subtracting. So for multiplying, dividing, we use ratio instead. Okay, so here it only tells us the explicit formula. We will also look at the recursive formula, but it's exactly the same thing. So no stress there. Okay, so my explicit formula is the same idea, right? A sub n, right? And this is my output, is equal to a sub 1, okay, times r to the n minus 1. Now, this is an exponential function, what we just finished talking about, right? You don't have to write this part down, but it's that y equals a times b to the x. The exact same thing, okay? Just different letters. Okay, so let's dissect this equation. A sub 1, we should hopefully already know, right? That's my first term. That is, what is the first number listed? It's a sub 1. My r, that's my multiplier. What am I multiplying by every single time? When we're talking about sequences, we call it the common ratio. So that's why we use the letter r's for that ratio. And then n, just like it was with arithmetic sequences, n is the term number. So if I want to know the 50th term, I would plug in 50 for n and then just solve it. So that's my explicit formula. Kind of make a little section off. My recursive formula, lucky for us, is exactly the same as arithmetic. So it's the next term in the sequence, a sub n plus 1, is equal to the current term, and then we just do times whatever my r is. So instead of adding d, right, I'm just multiplying by r. So it's just, what am I multiplying by every time? So in this problem, it would be a n plus 1 equals a sub n times 5. That's it. And then again, I also have to give the first term. Okay, so it's pretty much identical to arithmetic sequences. The only difference is you're just multiplying by r instead. So let's look at our first example and see if we can figure out how to use this equation. Okay, so our first example, it goes 2, 8, 32, 128. So if I had no idea what I was multiplying by, right, I can kind of look at the first one, how to go from 2 to 8. If I didn't know if it was arithmetic or geometric, I could say, well, I add 6, right, to go from 2 to 8. But I don't add 6 to go to 32, so that one's no good. Then I can say, okay, well, I also times 4. Okay, oh, and 8 times 4 is also 32, right? So that kind of helps. If I have no idea, we use that trick that r is equal to a sub 2 over a sub 1. The second term divided by the first term. My second term here is 8. Divided by my first term is 2. 8 divided by 2 is 4. So that tells me that my common ratio is 4. Okay, then it says find the next term. So I'm multiplying by 4 times 4, right? And then to get to the next term, I need to multiply by 4. So 128 times 4 is 512. So the next term in the sequence is 512. Okay, I'm going to try to write the explicit formula here, just really down low. Okay, write the explicit formula. So looking up above at our notes, the explicit formula is a sub n, right, equals my first term, which is 2, times my multiplier, or my ratio, which is 4, to the n minus 1. That's it. Okay. And then part C, so let me rewrite this equation. So n equals 2 times 4 to the n minus 1. Okay, and then part C says find the ninth term. So I want to plug in 9. So I have a sub 9, the ninth term, the ninth number in this sequence is equal to 2 times 4 to the 9 minus 1. So I just simplify, that gives me 2 times 4 to the 8th. And I can enter that into my calculator very carefully, and I get 131,000 and 72. So the ninth number in this sequence is 131,072, which makes sense. Like if I keep multiplying by 4, that number is going to increase really quickly. Okay. Okay, so I want you guys to try example 2. So go ahead and pause the video here. Look at example 2. Use the same method as example 1. And find the next term, write the explicit formula, and then find the 7th term in the sequence. Okay, hopefully you gave this a try. So let's look here. To go from -5 to 15, notice it's going negative, positive, and that's like kind of confusing, right? So to go from -5 to 15, I could add 20, but that doesn't get me to -45. So I also can multiply by -3, right? -5 times -3 is 15. 15 times -3 gets me -45. So my R here is -3. But again, if I didn't know that by looking at it, if I couldn't figure it out, I would use that ratio of my second term divided by my first term, which would get me 15 divided by -3. Oops, sorry. I'm ahead of myself. 15 divided by -5, and that equals -3. So that means that every single time I multiply by -3. So that means to get to my next term, I have to multiply by -3. So 135 times -3 is -405. So that is the next term in the sequence. Okay. The explicit formula is a sub n is equal to my first term, which is -5, times my multiplier. What am I multiplying by every time? Well, that is -3, to the n minus 1. And that is my explicit formula. Let me just scroll down here and rewrite that. So again, it was a sub n equals my first term times my common ratio, the n minus 1. And then part C, I want to know the 7th term. So I'm going to plug in n, or excuse me, plug in 7 wherever I see an n, -3, and then 7 minus 1. So this is -5 times -3 to the 6th. You have to be very careful with parentheses here if you're going to enter the whole thing into your graphing calculator, okay? So just be very careful. And I should get -3,645. If you did not get -3,645, you probably are entering it into your calculator incorrectly, and so that just might be something that we want to look at. Okay, last example, example 3. Go ahead and try that one as well. And then we're going to do one example back on our notebook after example 3, and then we'll be done. So go ahead, pause the video, go through this one, and then we'll do one more together. All right, so again here, if you're like, hey, I have no idea what I'm multiplying by every time, we can use our, I don't know why I wrote an A. Holy moly. We can use our common ratio, right? Second term divided by first term. So -6 divided by -3, which is 2. So I am multiplying by 2 every single time. Again, you don't have to use this formula. If you just can look at it and say, oh, I'm multiplying by 2, fine by me, okay? So then I need to multiply by 2 to get to my next term, which gives me -48 is my next term. And then I need to write the explicit equation or the explicit formula. So a sub n equals my first term, which is -3, times my multiplier, which is 2, to the n minus 1. And then lastly, I want to find the 13th term. Oops, I scrolled too far. There we go. I want to find the 13th term. So here's my explicit equation. negative 3 times 2 to the n minus 1. Okay, so to find the 13th term, I'm going to plug in 13 wherever I see an n. So I have 13 minus 1. So negative 3 times 2 to the 12th. Plug that into your graphing calculator very carefully, and you should get negative 12,288. So the 13th number in this sequence is negative 12,288. So hopefully that's making sense. The only reason I want to do one more example in our notebook is because if you notice, let's scroll back up, all of these, I was multiplying, like these numbers are getting bigger, right? Our multiplier is like 3, or what was it? It was 4, negative 3, and 2, right? What if I'm dividing by a number every single time? What does that look like? So let's go back to our notebook. Here's our notebook, right? We're going to glue in our sequence, our foldable, like here somewhere, right? And so we want to, somewhere on this paper, we want to do another example. So we're going to call this example 4. So just anywhere on your paper that you have room is fine. But I want to look here and what happens if you're dividing by a number every single time. So let's look at the arithmetic sequence. 48, 24, 12, 6, dot, 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 right? So it just continues on forever. So here, I need to kind of look at what am I multiplying by every time. And I hope you don't mind, I'm going to go ahead and kind of scroll down here a little bit just so I have more room since I write so big. I know you guys are much better and much more organized than I am. 48, 24, 12, 6, dot, dot, dot. Okay, so again, if you don't know, I'm like, I can tell it's dividing by 2, but here's the problem. In my explicit formula, there it is, I cannot put dividing by a number in here. I can only put numbers that I'm multiplying by. So to find that common ratio, we're going to use, whenever you're dividing, you're going to use that A2 over A1 trick. Okay, so my second term is 24. My first term is 48. This simplifies to 1/2. So that tells me that my common ratio is 1/2. I cannot put into my equation dividing by 2. Okay, so hopefully that makes sense. So then when I go to write the equation, I have a sub n equals my first term, which is 48. My multiplier is 1/2 to the n minus 1. And then from here, I'm able to find whatever term I want, right? If I want to find the 15th term, I just plug in 15 and whatnot. We're not going to do that part of it, but I just wanted to show you if you are dividing by a number every single time, you should be using this method right here of your second term over your first term and then just simplifying the fraction. If you need help on any part of this, please let me know, especially I know that when it's dividing, it can be a little bit more tricky. But if you have any questions, reach out. And otherwise, you guys are good to go, and we'll see you next video.